All right, so this is the second part of the 4.3 lesson. Here we're going to talk about the different types of logarithms and how to evaluate certain logarithms. So first up, we have that the common log is the logarithm with base 10, and it's typically written log of x. The natural logarithm is the logarithm with base e. Remember, previously we discussed that e was about 2.71828. And this is written ln of x. So in other words, ln of x is the same thing as log base e of x. These are the same thing. So let's look at some examples. Evaluate log of 1000 using the definition of the common log. Okay, so to evaluate log of 1000, we're trying to find some x that's equal to log of 1000. And also, just as a note, it's very common to write these logarithms without the parentheses. If I only have one term, it's very common. I'll try to use the parentheses whenever I can remember to place them, though. So, because this logarithm on the right-hand side has base 10, I can undo this logarithm by exponentiating both sides with a base of 10. And because on the right-hand side, my exponential base and my logarithmic base, notice this is the common log, so this is log base 10, those bases match, meaning they cancel each other, and I'm left with 1000 on the right-hand side. So what I'm really trying to find is some x that makes 10 to the x equal to 1000. Well, 10 cubed is equal to 1000, right? 10 times 10 times 10. This means that x is equal to 3. Looking at another example here, evaluate natural log of the square root of e. So maybe first, let's remember that if I'm taking the square root of a, I'm able to rewrite this as a to the 1/2 power. So I can rewrite natural log of square root of e to be natural log of e to the 1/2 power. And now this is log base e of e to the 1/2 power, right? Because natural log is log base e. Because my logarithmic and my exponential bases match here, I'm just left with what is my exponent here, which is 1/2. So log base e, or natural log of square root of e, is 1/2. This is just a calculator problem. We can type log of 500 into our calculators. We have a log button. If we type this into our calculators, this is asking the question, what power of x in this? What power of x do I have to raise 10 to in order to get 500? Right? If I type this expression into my calculator, this log of 500, I should get about 2.69897. So I have some properties of logarithms. The first property of logarithms that we're going to talk about is in this section. It's the exponent property. We'll discuss more properties of exponents in 4.4 and in 4.5. But for now, we're just going to talk about the exponent property. If I have, I'm going to rewrite this because it's maybe a little difficult to see in the box there. Log base b of a to the r power this is equal to r times log base b of a. Or in other words, if I have an exponent on the inside of my logarithm, I'm allowed to bring that in front of the logarithm as a constant term. I'm allowed to instead multiply the logarithm. Instead of raising the inside to this exponent, I can multiply the outside by this number. Let's look at how to use this. Let's look at some examples. Let's rewrite log base 3 of 25 using the exponent property for logarithms. So if I'm going to use this exponent property, I want there to be an exponent inside of my logarithm. And there can be, right? Because 25 is 5 squared. This means I'm looking at log base 3 of 5 squared, right? Log base 3 of 25 is equal to log base 3 of 5 squared. Now I'm allowed to take this 2 from the exponent and bring it in front of the logarithm and turn this into multiplication. So this becomes 2 times log base 3 of 5. Now we have rewrite 4 times natural log of x using the exponent property for logs. So this equivalence goes both ways. If I have 4 times natural log of x, I'm allowed to also take this number and bring it on the inside of the logarithm as an exponent. So this becomes natural log of x to the 4th. I also have this property called change of base. The change of base property allows for me to express my logarithm as a quotient of 2 other logarithms with different bases. So once again, it's maybe a little hard to see the letters here, so let's rewrite this. This is log base b of a is equal to log base c of a divided by log base c of lowercase b. So notice that the bases of these 2 logarithms match, right? And the argument of the logarithm in the denominator becomes the new base, right? The argument for the logarithm in the denominator here becomes this base. So let's look at some examples. Evaluate log base 2 of 10 using change of base formula. So this change of base formula actually allows us to type these logarithms into our calculator a little bit easier. That's kind of part of the point of them. So, well, and, you know, just being able to rewrite logarithms in general. But I can rewrite log base 2 of 10 as, say, log of 10 divided by log of 2. You could also say that this was something like a natural log of 10 divided by natural log of 2. The actual logarithm that you choose to use here doesn't matter because the base is getting changed anyway. So if you type in either of the expressions on the right here into your calculator, I'm into erase, there we go. If you type in either of those expressions, then you'll get the same answer, which is about 3.3219. And this is actually the answer to the question that we asked at the beginning of the section, in the beginning of the last video. It'll take about 3.32 weeks for the population of flies to grow to 500. And one more example. Evaluate log base 5 of 100. Okay, so we can maybe express this as log base 5 of 100 is what? We could say maybe this is log of 100 divided by log of 5. 100 is 10 squared, right? So log of 100 is going to be 2. And this is divided by log of 5, which is about 0.69897. And if I type this into the calculator, I get 2.861. That's it for this video. There will be one more video for 4.3.